So we got a little bit of an agenda. So in terms of this, so we're going to talk about who I am really briefly. The problem statement, some of the tools. We're going to go through an account and a network diagram, and then we'll talk through the Terraform solution. So we're going to do kind of a quick kind of go through some of the basics of Terraform for those that maybe are not familiar with it. And then we're going to switch over to, we're going to switch out of PowerPoint, which is a terrible medium to share source code, and actually look at some source code that we have that we're using with a client. It's been redacted in new code or new code and all that kind of stuff. So there's no secrets or anything, but we want to make sure that we can actually show some code that we use and that we work through to solve some of those problems. So who am I? These are some wonderful words that somebody who is good with words has said about me, which is kind of neat, but in general, I'm just I'm a DevOps guy. I enjoy solving problems. I enjoy taking, developer problems, operational problems, business problems, and finding solutions, and helping organizations and helping clients and helping teams just get better at doing what they do. And so sometimes that involves writing software. Sometimes that involves writing, API integrations. Sometimes that just involves kind of going through somebody's existing stack and just sort of doing an analysis. And really what it is it's what's the business problem? What is the problem we're trying to solve? And well, let's go solve it, right? So that's me in a nutshell. So I've got the AWS professional certs. HashiCorp has recently released a Terraform associate level cert. I completed that a couple weeks ago. Love to go through the different certifications. Got a couple of Azure certs. Kind of did those just to see if I could do them. And then my Google cert I think just expired, so I might have to go pick that one up again. But really, just like I said, love getting in and just kind of figuring things out. So the problem statement to sort of drive everything that we're going to talk about today is how do I manage multiple AWS accounts and resources spread across multiple regions in a simple, cost-effective way? Some of the desired attributes that we want to include in this particular system. Infrastructure as code. So we'll approach this from a perspective that we're starting with blank AWS accounts. Frequently that isn't the case, but we're going to kind of approach this from a perspective of we want to do this, in a repeatable, reproducible, auditable way. So that really lends itself to infrastructure as code. Today we're going to talk about Terraform. There's lots of different tools that can accomplish this, but today's is going to really be Terraform specific. We want a single source of truth for all of our AWS accounts, right? We want to have rapid deployment to new regions, and then we also want to make sure that we've got VPN access in and can manage that appropriately for all of our users. So we break some of those things out, like I talked with infrastructure as code, all things in code all the time for everything, right? We want an audit trail. We live and breathe inside of Git. Is generally the source code management we use. Git repository, whether it's GitHub or Bitbucket or whatever. Everything we're going to do, we want to check into code. We want to make sure that we do PRs and that we've got process that again is repeatable and auditable by really anybody inside of the organization. And again, Terraform, we're going to talk about that. A couple of big things with Terraform, state file management. I love Terraform's ability to really get in and muck around with a state file. CloudFormation tends to hide some of that a little bit from you. Not that that's bad, but there's certain pluses or minuses that come with that. With Terraform, they kind of lay it all out there bare, and that's something from my perspective. Again, getting in and being able to tweak and pull strings and twist knobs. I love to be able to just really own my state files and state file management. And then import. Like all code, you're going to go through and you're going to refactor your infrastructure. You're going to make changes. You're going to add improvements. You're going to subtract things. Stuff's going to change all of the time. Terraform's import process makes refactoring large chunks of code just a breeze. Very, very simple. It also, again, we talked, we're looking at this in some ways as I've got a blank account. That's not often the case. And often the case we have is we've got somebody that has a couple of accounts. They've got some services out there. That Terraform import process allows us to take those things, build code, and then bring them into the state file and start to manage them in that code. So we don't have to look at an account that's been created, whether it's been done with any tool or by hand, and go, well, that's neat. Now we got to migrate to this other thing. Instead, we can really manage and build those resources inside of Terraform and import those into the state file, and that's extremely powerful. In terms of rapid deployment of new regions, most applications live in a region, and then the business comes and they say, we want to go to Europe, or we want to go to active, or we want to go to this other place. And so being able to rapidly stand up all of the things that are necessary for somebody to use a particular region, it's not as simple as just flipping it on. There's more that goes into that. And so security is also a huge player in how you turn those regions on, how you manage those regions within AWS. And so being able to do that quickly so that the business says, you know what, this is great. We really want to do A/B testing across regions, or we really want to do more regional specific load balancing. Please turn us on. We're in Ohio and US East 2. Please put us in US West 2. And this is the type of thing that we can do that very quickly and very easily and really stamp that out. Single source of truth for AWS accounts. So accounts are not static. They will always be changing. IAM permissions, it seems like half of my job some days is just editing and managing IAM permissions and making sure that they're done appropriately, and then expanding that out and pushing all of that stuff out to multiple accounts, and then creating accounts for new projects. Some organizations love to have, instead of sort of separating things at a VPC level or at a networking level, they want to really isolate an application at the account level, which makes complete sense in different situations. So being able to create that account and manage it and make it a part of a larger organization of accounts, and to do that rapidly and be comfortable and confident that everything that you need from a regulatory compliance, everything you need from security, everything you need from a logging, all of those things are just stamped out in the new account, and you move forward with that. That's absolutely critical to really be able to answer those questions quickly. And then again, I mentioned VPN access and being able to access these dynamically created regions and VPCs and all of this stuff, right? Much like the accounts are sort of living and breathing, VPCs should also be living and breathing. And my personal opinion, more often than not, about the only two things that should ever live forever in an AWS environment would be your production space and potentially your tools, your shared services, those types of things. So, if you're hosting your own GitHub or you've got Jenkins running or those types of things, those kind of live forever, and your production environment lives forever. And everything else, whether it's a development environment or UAT or pre-prod or some other environment, those things should come and go as they're needed and shouldn't necessarily have to live forever. That saves a tremendous amount of money on cost, in terms of overhead, not just AWS, though those bills can get pretty exciting, but management and manpower, keeping track of what all these different environments do and how they work. And then you've got all sorts of different types of access, right? So you've got developers that are going to access some things, production support, data analysts, lots of different ways that different people need to access the system and be able to get around. So managing that VPN access and being able to tie all those things together very, very quickly and efficiently is definitely important. So quick overview of some of the tools we're going to kind of talk about, just really at a high level. So Terraform, from the HashiCorp site, Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. Cool. It's a very, very powerful tool. What's most exciting, especially those that have been using Terraform for a while, is watching Terraform sort of grow and change over time. From the way that it does execution plans, the way that it builds out its resource graphs, and really works to parallelize deployments and destruction and management of that infrastructure, in terms of how you can use it for change automation. And then obviously it's just automated and fast. There's ways that you can write tools, write scripts, it gives you a lot of flexibility in terms of that ability to really integrate it into an environment. Some of you might be asking, like, what about CloudFormation? What about Cloud Development Kit, Deployment Manager, those types of things. And like I say, those are all good tools. Multi-cloud tends to be part of the conversation, and so one argument for Terraform tends to be that I can learn Terraform, I can understand HCL, I can understand how that workflow works and exists inside of my ecosystem, and then I can extend that to any cloud, and I don't have to learn new tools or different tools for the different clouds that I interact with. That's not to say that CloudFormation or ARM templates or any of that kind of stuff is bad. In fact, one of the best ways still to this day to manage an auto scaling group inside of Amazon is to do it with CloudFormation, because for whatever reason, AWS in its infinite wisdom has said all things via the API, except how you do updates to auto scaling groups. That one we're going to hide away somewhere and make that an only CloudFormation thing. So there are still nuggets here and there that you have to use the various tools. And so it really becomes what's the right tool for the job. And so again, while those aren't bad tools by any stretch of the imagination, and if you have certain requirements and certain things are good, my personal preference is generally going to be Terraform, or I'm going to tend to lean, unless there's a good business reason or business case for moving away from it. In terms of CI/CD, so everybody I think is probably familiar with CI/CD in terms of continuous integration and continuous deployment. The question that I often ask folks that are sort of getting up to speed on infrastructure as code is, why are you treating your infrastructure any different, right? Why are you, why are you producing runbooks, or why are you producing, piles of documentation and your hand going through and modifying or changing things? Why are we doing that when we don't ask that of our developers? Our developers are, we're spending a lot of time building out these environments that allow the development teams to just sort of commit and let all of these things occur in an automated way. Why are we treating our infrastructure any different? For a long time that was a necessary evil. It really isn't necessary anymore. And typically, again, are you nuts? Why would you automate infrastructure? And I'm not advocating that day one you flip the switch and as soon as I make a change in master, she rolls all the way out to prod. Obviously, there, would certainly recommend gates along the way. I think there's only really been maybe 2 systems that I've ever worked on, probably in the last 3 to 4 years, that really truly were continuous integration, continuous deployment, where we would, something would get to master and it would go through the appropriate environments with tests along the way and then eventually show up to prod without really any manual gates to get it there. Some of the common tools, again, Jenkins, Concourse, Circle CI. AWS itself has some different tools that are pretty cool. I use these for personal projects, just because they're nicely integrated into the integrated in the AWS environment, and I can kind of manage my single bill a little bit easier. And then other thing I would mention to folks is, don't forget that your orchestration jobs, everything that you do should be in code. So whether it's Concourse, Circle CI, or even Jenkins, at this point, we don't deploy Jenkins anymore unless that Jenkins configuration is in code. We don't deploy jobs to Jenkins unless we're using the job DSL, and we don't create jobs unless we have Jenkins files or pipeline files to manage all of those things. Everything really needs to be in code. And so when we look at a problem, or we look at a business issue that we're trying to solve, we really want to come at this from the perspective of code first. And Jenkins especially has matured quite a bit, but a lot of these tools have matured in that particular direction and continue to mature from that code first mentality, which is really exciting because it gives you so many more options in terms of how you manage these things moving forward. We're getting to the point now where we could actually shut and tear all of the Jenkins infrastructure down if nobody's going to be around from 5 p.m. to 8 a.m., not pay for it, and then spin it up completely fresh at the first thing in the morning, deploy all the jobs, and we're ready to go when somebody shows up and wants to do some work. Jenkins is there and it's ready to go, right? So those types of things, in terms of cost savings, in terms of security and management of resources, are absolutely possible, but they're really only possible if you really focus on that code first mentality. And then there are hundreds, I think, at this point, AWS servers, and there's new ones every day. Some of the big ones that we're going to kind of talk about and touch on here when we get into some of the code, and I just kind of want to give a quick overview of some of those. We're going to talk about organizations, CloudTrail and Config, which are some of the security-based services that AWS provides. Identity and access management, which is the big one. Like I said, that's one that it's a fun one, because if you get in there and you don't do it right, you can actually lock yourself entirely out of an account, and you're on the phone with AWS support to ask them to try and try and fix it. So that one gets to be fun. S3, S3 is sort of ends up becoming the home of just about everything, and so being able to manage your S3 buckets and retention policies and rotation, versioning, all of those types of things is definitely going to be critically important. And then CloudWatch. Lots and lots of services within Amazon. Shocker here, naturally log all of their events into CloudWatch. So being able to understand how to manage CloudWatch log groups, setting the retention appropriately, so you're not paying for years of retention there, and managing those things correctly are certainly important. And then from the networking services perspective, so we're going to talk a little bit about Transit Gateway, VPCs, the AWS Client VPN, Route 53 and Route 53 resolvers. Route 53 resolvers is actually something that I've been playing around with here since they came out, and they are probably one of my favorite tools. DNS was always painful in AWS environments, and Route 53 resolvers have really done a tremendous job of making DNS really not an issue anymore, and has really made a lot of the dynamic environments that we build and we manage, has really made those much simpler to understand and to communicate out to folks. And so Route 53 resolvers are a big component. So let's talk about some diagrams, right? So I'm gonna kind of show you the blueprints of the house before we talk about how we built the house and how we put the house together, just to kind of hopefully orient some folks, as we're kind of looking through this, to what it is and how we put these things together. So this is sort of the master account diagram. And it's sort of a probably hub and spoke model for accounts. We have one master account. Obviously, organizations can have multiple master accounts, but this is how a master account would sort of look. And so we've decided our primary region is going to be US East 2. We're going to create a transit VPC. The transit VPC is really not going to contain very many resources. It's really there that we've got we can attach the transit gateway to it. We can attach our client VPN to it, and our Route 53 resolvers. And so it's really there for what I would consider global services that are going to be available really to any of the VPCs that connect via the transit gateway. And we're going to talk about a tools VPC. So the tools VPC, so you'll see here in the transit VPC, we've got public subnets, we've got an internet gateway, and we've got, the sort of your standard subnet layout. Tools VPC is going to be just private subnets. So we don't actually have public subnets in here. All of the internet traffic is going to route over the transit gateway out through the internet gateway itself. As we build things out in the master account, occasionally organizations come in and they're like, hey, this is cool, but we want to start doing, egress traffic filtering. Great. In the master account, you're essentially going to replace that internet gateway with some sort of probably a marketplace tool. Whether it's I can't suddenly think of the name of the company that does it, but whether you're looking at a marketplace tool to do the egress traffic filtering, whether it's a Cisco product or something to that effect. Once you've got that in place, all of the other VPCs are just naturally routing their traffic through there. So this is a pretty good model to really manage and understand where your internet traffic's going. And then outside of that, but still sort of in the account, we're going to talk about organizations, CloudTrail, AWS config, like I said, Route 53, and identity access management. And there are really a number of different things that we'll plug into an account as we build those things out. And where I say that this is something that, again, an AWS account is very much living and breathing. AWS config rules are something that if you've decided to use AWS config, you'll be adding rules as your infrastructure and as your services grow. You'll add new rules to manage and validate configs as they grow in, right? AWS identity access management, the IAM stuff, again, is another thing that over time will just sort of grow and grow. And so understanding the fundamentals of how you manage that in code and do that so that you can stamp that out is definitely important. Now, when we look at our sub account or child accounts, let's say that we've got, so we still have our link to our master gateway, or essentially the transit gateway, in the master account. But here we're going to do some services in US East 2, and we're going to have some services in US West 2, right? So we're going to do some stuff in Ohio and Oregon. We're going to have 2 product VPCs that are deployed into US East 2, and we've got another product VPC that's going to be deployed out in US West 2. All of that traffic is going to route up through, all of those VPCs are going to be accessible via that transit gateway. But if you notice, we have internet gateways in each one of these. So instead of routing all of their internet-based traffic or all their internet-bound traffic out, through that transit gateway and through that single internet gateway. Each of these are sort of independent as they are separate accounts and they're sort of separate product VPCs. So we manage sort of internet traffic and internet access to services inside of those VPCs accordingly. So really these lines connecting these back to that transit gateway are for access. So whether it's developers needing access to a developer environment, whether it's the production support folks need access to some sort of back-end administrative tool, whatever it may be, the hooking those up to that AWS transit gateway is what allows for that, creates that ability. And then it goes inside of those AWS accounts. We have, AWS keys we'll set up if we're using Secrets Manager. Again, lots of identity and access management rules, Route 53, because again, we want, as we spin up, so if I spin up newco.net and then I create the dev instance of dev.newco.net, and then I've got maybe newcode.io as my product, is my public facing address. When I create dev, I want to be able to wire up all of the DNS so that the dev account has all of the appropriate DNS so that folks can do testing on that DNS. And I'm not doing things with IP addresses. But at the same time, when I tear it down, I want it to all go away. And then obviously we've got a lot of S3 buckets and like I mentioned, the Route 53 stuff. So this is sort of the high level of what we're going to do from an account perspective, is build that master account, and then we're going to sort of stamp out these sub accounts. So how do we sort of put all this together? So the foundation of all of this, again, is going to be Terraform. Question that gets asked more and more is, you're going to use the CLI or the open source version versus Terraform Cloud versus Terraform Enterprise? Frankly, that's really a question for the organization and the maturity level. My personal opinion, if you're getting started and you have never really done anything, I tend to like the simplest solution because I get to learn more and understand it better. So that's why I tend to point folks more towards the CLI. Terraform Cloud, still relatively new, but is definitely an option depending on again the maturity of the organization. And Terraform Enterprise. I generally don't recommend organizations jump right on the Terraform Enterprise bandwagon until they understand and kind of understand what Terraform is going to do for them. I think it's easier to understand how all the gears move before you put a box around all the gears. So that's just kind of a personal opinion. Not that they're bad services. It's just that's just kind of how I sort of look at them. And then the question always comes up is, do you want to pin your version? So Terraform is one of those tools that is not backwards compatible. So if I have a state file that I've run Terraform 0.12.11 on, and then somebody comes through and they run 0.12.12, it'll update the minimum required version of the state file to 0.12.12. And the next time I try to run it with my installed version of .11, it will fail. And it will tell me that, hey, you need to upgrade your Terraform version. Generally, not a huge deal. But when you get into a situation where you're doing something with Jenkins, or you're doing it with Concourse or whatever CI/CD tool, and that tool has a specific version, my general recommendation is it tends to be to pin your Terraform version to whatever you're running inside of Jenkins. And that way, if somebody does check out some code and they're playing around with the development environment and they pull the latest and greatest, which might be 12.14, and they pull it down, they don't essentially poison all of your state files. The Terraform required version will sort of pin that. As far as required providers and the different providers within Terraform, I generally just say, let's pick whatever the latest version in, but allow to pull in from whatever the latest one is as it goes. Those, again, you can pin those. The AWS one changes pretty frequently as far as open source tools, as there's new stuff that comes in from AWS on the API. And so the latest one tends to be pretty useful. So I'll let that one go. But in terms of Terraform, again, generally recommend that we pin that just to make sure that somebody on the team doesn't accidentally make a change, and now we're forced to upgrade as a group. And then as far as source code management, so Terraform modules themselves all get checked into source code. Really all of this does. There's two main schools of thought. You sort of have your single repository where you have lots of different modules, and you have multiple repositories. that one is just really up to how you want to manage it. I generally like the single repository where I have lots and lots of directories and things that I reference out of there. If you're going to go the Terraform Cloud or TFE, or you start to use the Terraform repositories that exist out there, you're going to probably want to go the multiple repository route. There's no wrong answer. There's no right answer, I guess, in my opinion. Like, as long as it's checked in, my requirements are satisfied. So it really is just it's really my opinion is personal preference on which way you want to go. I don't really believe either is bad. And then as far as the Terraform code, so again, whether you want to go the mono repo route and sort of check everything in, or you want to have individual repositories for each of the different chunks of code, that's really, again, that really comes down to sort of the preference of the team and how they want to work. State files. So I mentioned earlier that state files are probably my favorite thing about Terraform, and the way that they do their state file stuff. Wasn't always the case. Early Terraform state files are pretty scary. They've got some pretty good stuff, pretty good management of those state files managed around that now. But this is where the crown jewels are. So this is where your entire organization, your AWS infrastructure, or whatever infrastructure you're managing with Terraform, all of that is represented in the state file. And so you definitely want to make sure that you put security around those. Something that is absolutely critical, I mentioned this with security also, if you put it in the state file, it's in clear text. So if you make a variable and that variable is an API key, and you plug that in on the command line, that API key is going in your state file, and it's going to be in clear text. There is no encryption of the state file information. So that's definitely something to be aware of, and as you're moving forward. And there's lots of ways to work with that and do it safely and to do it securely. But that's definitely something that's caught some folks before, is they're like, well, I'll just make that a variable. Cool. But now you've poisoned your state files with secrets. There's lots and lots of options, but I would highly recommend that you never use the local storage. You get a little bit of a chicken and an egg, right? So, I want to manage my bucket that I'm, if I'm going to do S3, I want to manage my Terraform backend bucket, but I need to bucket to manage my bucket. So that's probably the one manually created object, maybe a couple of SSM permissions or parameters, but generally create the bucket manually and then import it across so that you're then managing that bucket long term. And we'll kind of show some of that in the code as well. And then, like I said, you can't go wrong with S3. You can do versioning, logging. You can apply some pretty stringent bucket policies and what's allowed in and out, who can do it, who can access those things. Number of state files is always a question. And so again, as sort of personal preference, I like smaller, more manageable bytes of code. So I don't, we could run all of this in one giant state file, or we can sort of break it out into logical groups. I tend to look at smaller groupings. So I've got my master account stuff, and then I've got my VPC stuff, and then I've got my DNS zones. Those are each individual state files. Makes Terraform run a little smoother. Also makes it a little easier when you're trying to understand what one particular component is managing or touching. And then, so I've got an example Terraform backend configuration. So this is an S3. So we specify the bucket, we specify the key. So this is going to be the name of the backend file, what region we're going to plug it into, and then the encryption. All of these. So this one is just a pretty standard backend bucket. You'll notice that there's no API information here. In terms of API key or API secret, that Terraform is going to pull in from whatever your local bash profile will be. So it uses the standard AWS API process to gather in whether it's a profile or you have keys established in your environment, or you're using SAML, whatever it may be. Terraform will read from those and access that information, and then import. And I can't stress this enough. Import into a state file is wonderful. So state file management, once you understand Terraform from a process perspective, where I initialize my Terraform repository, where it pulls in all of my providers and pulls in all of the modules, etc. And then I do a plan and I see what it's going to go do, and then I apply. The next thing that I highly recommend to everybody really get to know and get comfortable with is importing and managing the state file information using the Terraform tools. It's extremely powerful. I can't tell you the number of times that we build something, right? And then you go back in a month or you go back in 6 months and you're like, it's just not working for me. I need to put that over here, or I need to move this into this other, and I need to do general refactoring, right? Just like you would do with code, managing those state files using import just allows you so much power in how you refactor your Terraform code moving forward. Workspaces. So workspaces are incredibly powerful and utilize those a lot. Workspaces are a little bit different between the open source CLI version and Terraform Cloud and Terraform Enterprise. So there are a couple of differences in how those get managed. Essentially, with Cloud and with Enterprise, there are additional permissions that you can put on top of those workspaces. There's some additional things that you can use to manage those a little more clearly. With the CLI, it really just allows you to utilize and maximize your code reuse. And so we've got an example here of some local variables, and you'll notice that we're oops, look at that, trying to highlight stuff. We're using that Terraform workspace as part of the name of something. So if we're just on the default workspace, which is what we get by when we just initialize a directory, this VPC name is just going to be transit. But if I want to build something and test it, I can actually create a dev workspace, and my variables will all update appropriately, so that they're now instead of naming it transit, now it names it transit dev, for example. So workspaces are definitely very powerful, and were a great addition to Terraform when they were added. And then providers. So providers would be the second really, really powerful component of Terraform. And so they manage all of the API interactions. So you can think of it as the AWS, I've got Kafka and Google. There are a ton of providers out there. And it seems like new ones sort of pop up every day. I was doing some stuff with a VPN provider called Aviatrix. They wrote their own Terraform provider, and you can manage a lot of their resources directly in Terraform. GitHub itself has a Terraform provider, right? So there's lots. It's basically just managing those API interactions. And if you can't find one, write one. Writing a Terraform provider is actually not that difficult. So as long as you understand Golang and you understand how the API, whatever API it is that you're going to interact with, it's pretty easy to actually sit down and actually write your own Terraform provider. We've done it a couple of times when it was necessary. We don't like to if we don't have to, because it's additional code. Obviously, you have to manage and maintain. But if you don't have a better option and you really want to manage something with Terraform, writing your own providers is certainly a great way to go. So on the left-hand side here, so we just have a real simple provider layout where we've got 3 AWS providers. You can use an alias, and so what that'll allow you to do is actually reference the US East provider versus the US West provider versus the default provider, and this allows us to then specify different regions. And so when we start talking about multi-region deployments, we start talking about multi-account deployments, being able to be very specific in terms of what the provider and what creds or what region we're going to work in is extremely powerful, and those providers allow for that. And so we've got another example over here where within a single set of code, we may talk to whatever workspace we're in, we'll grab that role. So if we're in the new code dev workspace, we'll grab the role for new code dev, we'll assume that role and be able to operate in that particular account and do that for whatever region we're doing a deployment to, and then US East 1. So if anybody's ever done any deployments with CloudFront, for example, if you associate an Amazon certificate manager, an ACM certificate with your CloudFront, that ACM cert has to live in US East 1. It's just the rules of the game. So automatically, if you're doing anything with CloudFront and anything with SSL and anything with ACM, you're going to have to figure out how multiple providers work and really get that to work so that everything can cleanly come together then for you. And so this is an example of how that would work, right? And then there's a Kafka provider. So this Kafka, and this one's an open source one, allows you to create topics, manage ACLs. So you can do some of that stuff inside of Terraform, again, all within the same sort of state file, same sort of managed component. And then you could also do some stuff in Google. So here would be a situation where we could have an AWS instance that is, and a Google instance, and maybe a Kafka bus, and we've got permissions that allow it to talk between both clouds. You can do all of that inside of sort of a single set of infrastructure if you wanted to. And then one of the very powerful things, and this has been around in Terraform for quite a while, is being able to build modules, being able to modularize your code, put those things together, and really build out modules for reuse. So here's an example of a very, very simple module. We've got just simply a variable alias, and then the resource that it's going to create. So this, and then we've got an example here where I'm going to call that module. So anytime I want to actually do that, or build this account alias, instead of having this resource listed everywhere and sort of copy and paste in that, I can actually use this module. This allows me to then sort of build modules of modules, and this tends to grow and get pretty big. There's kind of a couple of different trains of thought on the modules themselves, whether it's single resource per module or multiple resources. I just sort of tend to lean to whatever makes sense. And so if I'm building out a static website, for example, that has CloudFront, ACM, a web application firewall, an S3 bucket, maybe a Lambda function to validate things that are in the S3 bucket, I'll put all of that stuff inside of one module, so that when I go, hey, I need a static site, I just call that one module, supply the variables that are necessary, and Terraform will then take care of building all of that stuff out. And then obviously we reference that, and you can reference that through a number of different sources. Most of the stuff we're going to look at tonight, I'm referencing as far as Git, in terms of a Git repository, and specify the folder and the revision that we want to pull in. So this would be a tag or a branch in that repository. So this would be a little more complicated module. So this would be a multi-purpose module for an S3 bucket. And so inside of here, you'll see whether or not we're going to enable a versioning, how we're going to manage the server-side encryption. And then we've got these dynamic blocks. And so with Terraform 12, dynamic blocks were added to essentially allow you to dynamically decide whether or not you specify. So for example, logging bucket, I want logging in here. I may have, my logging bucket, I don't want it necessarily logging to a logging bucket, because then I get into a nice loop there. So for my logging buckets, I don't specify logging bucket, right? And so it doesn't set all of those things up, but I can set up my lifecycle rules, and then if there are changes in region, I can ignore that. And so then I'm not going to see those things. And then as far as a module is concerned, this is another module where I've got two resources defined. So I want to make sure that I've specified that blocking public ACLs and policy and all of those types of things are true by default all the time, unless this is an S3 website or I'm using it as a 301 direct bucket. And in which case, I don't turn those on, right? So you can start to sort of build out more and more complex modules that you can reuse with different variables and different sets, and that allows you to really save on the amount of code and the amount of stuff that you have to write and maintain over time. Speaking of code, let's take a look at some code. I guess let me ask this: are there any questions so far? See if I can figure out how to chat. Oh, nobody's got any questions on there. Oops, that's not that part. All right. So let's look at some code. So we got over here, and I know it's small. Adam's kind of got a thing. I actually don't know how to make that bigger, but when we look at the code, it'll be bigger. So we've got a set of Terraform modules, and so these are just sort of some random ones that we've copied. So we've I've got Route 53 record managements or zone associations, resolver rules, organization modules. These are all things that we sort of built and customized really for a particular client that we're working with. But the big one, the really big and important one, would be the account setup. So inside of account setup, we're going to define account alerts, and so these would be all of the various alerts by the CIS benchmarks for an AWS account. Every time we utilize this module, it's going to stamp all of these alerts out for us automatically. Now you'll notice that we've actually have a source in here that is this account alert. So we actually have a module within a module. And so again, to sort of break down the amount of code that we have to create, that's what this allows us to do. So instead of stamping this out multiple times, we put this into a module, and then we've we've got far less code to duplicate.
Oh my God.
What? Sorry, was there a question?
You're good. I think it was an accidental unmute.
Oh, cool. All right, moving on. So from here, we've got administrative policies. We've got API gateways set up, right? So all of the things that are going to be necessary are Jenkins policy that we're going to create, power user policy, password, account alias, all of those types of things we're going to go create, and we're going to set all that stuff up every time we stamp out an account. And so by grouping all of this information together inside of that module, it makes it very, very easy and very repeatable for us to then go, okay, I have a master account. It has this set of information. Boom. Now it's out and it's done. Now I'm going to create a sub account. It's going to have very similar, the same information. Boom. Now it's done, and so on and so forth. And this also extends all the way down to regional resources. And so when we look at regional resources, there are certain things that we want to put in every region. So that would be, if we've got CloudFront, a logging bucket for CloudFront, maybe a Lambda staging bucket if we're going to deploy Lambda functions, a logging bucket for all of our load balancers. And so every time we open up a new region, there's a set of things that we're going to deploy out to that region. By putting all of this in that one place, again, as we mentioned earlier, by having those accounts being living and breathing, as requirements change, I'm coming in here, I'm making some changes, and then I can deploy that out to whatever number of accounts that I have, and I can keep all of those accounts in sync very, very easily and very efficiently. And so we look at our S3 logging bucket, alert topics, SSM keys, VPC logging buckets, all of that type of stuff. The default VPC, so of course, as part of CIS, you need to make sure that the default VPC has flow logs on, and that the default VPC security group is, tightened down, closed down. So there's lots of, so again, when I extend to a new region, I want to make sure that as I extend to that new region, that I have appropriately managed all of those resources inside of there, and I've basically set that region up so that I can now drop in applications, and I can be comfortable and confident that the security, logging infrastructure, all of the things that are necessary for that region to come online are just online. So when we look at how that would work inside of a master account setup, for example, so this module essentially for the master account is going to take care of managing how that works. So I'm going to specify my account alias that goes in, whether or not it's the master account. And so based on this, there are some different things that will take place. So if we look back at IAM roles. So if it's a master account, I want to assume that role was SAML. So I'm utilizing SAML to federate my accounts into AWS. But if I'm not in the master account, then I'm just utilizing the good old standard assume role. And so by specifying that master account, this allows me to essentially play with my actions on those IAM policies and manage all of that, again, inside of one place. So I have one administrative policy that goes out across all of my accounts, one power user policy, one Jenkins policy, param, et cetera, et cetera. Those goes across all the accounts, and then I can manage access to those and manage how you assume those roles based on which account that it's in. It's terribly unfortunate I don't have my camera on. I do great visual representations with my hands right now. So if we're looking at that master account, then so any special power user policies or any cross account things that we would want to add to that particular master account or into any of those other accounts, we can specify those there. Again, we're referencing that in Git, and we've got a specific version that we're referencing, and that prevents us. Somebody goes in and they make some changes and they release a new version. I can do a plan and I can see, hey, did that change anything that caused any problems? But generally I can sort of leave it there and sort of pin it to that particular version. And then all of my providers. So in this case, we're deploying out to US East 1, US West 2, and US East 2. So that is the default region. So we specify our providers, and then we pass that provider list on to the module so that it can go and actually do all of those things in the various regions that it needs to do the work in. Backend bucket is a great example of utilizing the bucket to create our backend. In this particular case, we're actually building a replication policies and replicating all of our data that's in the. So we create our bucket in US East 2 for all of our backend management. But I want to make sure I have all of that data replicated to a second region. And so, I mean, that is the crown jewels after all. So I've set up inside of Terraform a policy that for this particular bucket, all of that is going to be replicated over to US West 2 to a separate bucket. And so I can manage and do all of that inside of here as part of that master account stamp out. If we were to go and build out a second master account somewhere, essentially by the account alias, we would create a different account alias, and we would be able to stamp that out, and we would get all of those things, and all those regions would come online and be ready to go. Developer role. So this is something that's definitely important, and so this actually will allow developers to come in and assume a role with SAML. But this role only lives in the master account because that's the only account that the developers have access to log into. So even here is where we can start to, okay, master account, all of this stuff is common across all of accounts, like logging buckets and AWS config rules and SSM keys need to be created, SNS topics, etc. All of that stuff is common across all the accounts. This is something that's specific to the master account. Cool. We'll put that just in the master account component. We'll still reference modules, and we can say, hey, just create this role here, and grant those developers the ability to assume a power user role in this particular account, which is a fake account number. We can manage our SAML provider, and then using AWS organizations, we can also manage the new accounts that we create for NewCo, right? So in here is where I'm going to create and sort of stamp out those various accounts. And all of that rolls up inside then AWS organizations. And so again, I've got dev and prod. Let's say I decide I need, app 3 needs a new account. Great. I'm going to come in here to the sub accounts. I'm going to create a new account, attach the account policy to it, and that'll stand up that account. And then I can go over to sub accounts and deploy all of that stuff and really prepare and get that account ready to go very quickly and very easily. And be sure that, again, all of the stuff that is important is moved along with it. And then in terms of the sub account is where we then manage all of our sub account stuff. So again, every sub account right now is picking up all of the different regions. This could even be something that you specify, like, hey, I'm a sub account, and this is the only region I want you to deploy to. Cool. That's a modification we can make to the account setup module, and we can make the account setup and make that based off of the workspace. Account regions sub accounts is actually a great use case for workspaces. So if we do a workspace list, we'll see that we have a NewCo dev and a NewCo prod. So this is where then we're going to manage. So we've got the same code or very similar code, and we're going to utilize that workspace. So if we wanted to do work in the dev account, we would just simply select that particular account, and then we can start to interact and do the work we needed to do in that account. This is where things get a little different between the open source version and the Terraform Cloud or Terraform Enterprise versions. In Terraform Enterprise, Terraform Cloud, you're really managing these inside of the Terraform Cloud infrastructure in terms of who can do that. On the open source version, you're really managing that. You can manage that locally, or you can manage it within Terraform itself. We tend to write Jenkins wrappers or Confluence wrappers around this so that it takes care and manages what accounts it works into and works with. We create CloudFormation buckets, create our organizational policy that specifies what resources are allowed to work with things and do things, and all of that inside of that sub account. From there, once we've got our account set up, we can create our transit VPC. So again, you're going to see on the transit VPC itself, so we're utilizing modules again. So we're trying to, again, reuse as much code as possible. We're going to build up our VPC, our public tier. We get our internet gateway, our private tier, put our NAT in there, and then we're actually going to create a transit gateway with the accounts that we're going to share it with. And then update or attach then the VPC to that transit gateway and specify which subnets, et cetera, that we're going to put on that. And then when we deploy our environment VPCs, providers again is what makes the magic work. We can specify our master and our transit account, and those don't necessarily have to be the same thing, along with the deployment account that we're working with, and then our peered VPC if we're going to work in a peer VPC region. So if I create a dev VPC in US East 2, I want to peer it with a region or a VPC in US West 2. I treat those are separate VPCs, I can still manage that within the same code base, and I can still manage that very cleanly inside of the same infrastructure and the same Terraform code. It just really depends on what workspace I'm in and what variables I supply in terms of what regions I want to deploy to. This also includes all of our, all of the DNS stuff that we would do inside of here as well. Again, it comes down to specifying what account or what provider we want to work with or talk to when we're setting up, whether it's a private zone or a public zone, however we want to manage that. So the same would be true of the tools VPC, and then the same would also be true with our client VPN. So client VPN, we would essentially establish a bucket. So here's a bucket that we've got that we're going to have some certificates in. So we are limiting that down to a specific set of users that can access that bucket. Otherwise, you get straight denial. And then set up our client VPN connection, set up our client VPN routes and tiers, what traffic we want to come through, and where we want that to go. Something that makes Terraform extremely powerful are its data sources. And so being able to say, I need to get the client VPN cert that I created for the server and the root in ACM, and I may have done that someplace else, and I can use that data source to pull that in. The same thing is true with the subnets and the VPC, those types of things, and I can reference those. And if I try to run my Terraform, one of the first things it does is it actually tries to pull in the data from those data sources. And if either my naming is off or I've got some sort of issue, it's going to alert me to that immediately and say, hey, I couldn't find any subnets with this particular name. What's up with that, right? And so that's a very powerful component to Terraform that we utilize quite a bit. And inside of those providers, you can also specify, or inside of those data sources, you can tell it which provider, what account we want to gather that information from. So when you sort of tie all of that together, what you're left with is a very, very small code footprint to manage a very, very large and ever-changing, ever-growing environment of AWS accounts, AWS VPCs, how you interact and connect to those different VPCs. And this really allows you to then, from an environment VPC perspective, I can stand up a UAT VPC or a pre-prod VPC, work with it for an hour and tear it down, and then come back in 2 days and stand it up again. And because all of that is in a nice, simple Terraform package, or essentially a set of modules and whatnot, it's very easy and very rapid for me to deploy that and tear all that stuff down. And I can manage that across multiple accounts. I can manage that across multiple regions, and really tie all those things together very, very simply. From an operational perspective, and make things relatively easy for me to then go to the business folks and be like, hey, want to do A/B testing, or we want to do backups in this region over here, or we want to release in something in Europe and GDPR has us concerned, or whatever the case may be. We have the Terraform frameworks are really already in place, that we can go ahead and we'll just create you a new account. We'll publish you out there. If we need to create a transit VPC over there and have a separate account structure or networking structure, no problem, right? We can, utilizing our Terraform workspaces and utilizing our Terraform modules that we already have established, we can readily stamp out whatever is necessary in whatever regions or environments that we need to. So, and I think that concludes my rambling. So we'll definitely open it up to questions at this point. Okay, so there's a question. Can you show an example of how you are handling cert management when you are redeploying CI/CD tools or products to a different region? I think I have some code that will do that. Let me take a look here quick. Exit out of that. Get to the right stuff here. So, shoot, you know what? I don't know if I do have any code that will show how that works. So we do have from, so I kind of went through and just randomly copied some stuff. And then, like I said, abstracted out. And so it doesn't look like I picked up any of the ACM stuff. Now, the one gotcha I would certainly let you know ahead of time when it comes to ACM certs. When you are doing dynamic environments and you're standing up and tearing down and you're doing a lot of ACM work, The ACM limits are pretty small, and so you'll lock yourself out of your ACM account pretty quick. So if you're going to do an account with dynamic environments, I would absolutely make sure that you reach out to AWS support and get your ACM certificate creation limits increased. Yeah, sorry. The only reference I really have to ACM certs right now is the data sources that we pull that in. I don't really have any. I don't have any other examples of that available. Sorry. We do it. I just didn't grab that code as an example. So sorry. I think I'll turn it back over to you, Mike.
All right. Thanks a lot, Eric. That was great.
Yeah.
I definitely learned a lot. So really appreciate you doing that.
Absolutely.